Okay, so in 4.2, we're going to talk about experiments. So 4.2. Experiments, and this will be part 1. So experiments. So let's take a look and find out, first of all, what exactly is an experiment, okay? When in statistics, the opposite, or not the opposite, what is not an experiment is called an observational study. Okay, it's called an observational study. Okay, so let's guess, or let's think what the difference between an experiment and observational study is. Okay, so if you go to page 242, the definition of an observational study says that an observational study observes individuals and measures variables of interest, does not attempt to influence the responses. Okay, in other words, you're not doing anything to the people that or whatever that you're looking at, right? You're just observing them. Okay, right. So you're not actually poking or prodding or giving them drugs or whatever it may be. Okay, so you're not actually doing anything. You're just observing what's happening. Okay, so that versus an experiment. So if you look at it, an experiment is where something where you're going to do. You actually now you're going to give drugs to the person. You're going to go ahead and I don't know. Let's see. Well, so we can do that. We can so basically like the studies for the vaccine, right? The vaccine, right? You're gonna give them the vaccine, see how they work, right? See what happens to them, that kind of stuff, right? So that would be an experiment because you're actually doing something to people that you're observing, right? You're looking at, right? So if you look at there on the bottom part of page 242, there's some definitions there. A response variable measures the outcome of a study. An explanatory variable may help explain or predict changes to the response variable, okay? So again, the explanatory variable is what we usually call the X. The response variable is something that responds to the explanatory variable, usually on the Y, but on the Y side, right? Okay. So now there are some things, right? You can experiment, and some things you can't, right? I mean, let's say that you are trying to study the adverse effects of nicotine, right? And you can't just go ahead and do a random sample, bring in 100 people, and 50 people, make them smoke a pack a day, and the other 50 people, you're still going to make them not smoke, right? Why can't you do that? That's pretty unethical, right? You don't want, you could potentially kill these people, right? So you don't want to, you can't go ahead and do it that way. So there are some things you can do, but some things you can't. Okay. So let's look at it this way. Let's go to the bottom of page 242. There's a little table there. There's a variable, okay, vitamin. So, okay, let's go. So there's a paragraph on top of that. Unfortunately, it's very difficult to show that taking vitamin D causes a lower risk of diabetes using an observational study. Okay, as shown in the table, there are many possible differences between the group of people with high vitamin D concentration and the group of people with low vitamin D concentration. Okay, in other words, let's say that they were trying to study and find out what's happening between the people who have high vitamin D and people who have low vitamin D, right? And they're trying to go ahead and make an experiment to see how that works. But the problem is what? The problem is that there could be other things that's not necessarily just the vitamin D, but other things could be kind of melded in your thing, and unbeknownst to you, it could affect the outcome of the response variable, right? And these things are what we call confounding. Okay, they are confounding factors. So you go to page 233, the definition of confounding. Confounding occurs when the two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. Okay, so this would be a bad way to do an experiment, right? If you have the confounding factors. As a matter of fact, so one of the biggest things about designing an experiment is to reduce or get rid of, remove these confounding factors, okay? Let's go ahead and read the example. Smoking and ADHD. In a study of more than 4,700 children, research from the Cincinnati Children's Hospital Medical Center found that those children with mothers whose mothers smoked during pregnancy were more than twice as likely to develop ADHD as children whose mothers had not smoked. Explain how confounding makes it unreasonable to conclude that a mother's smoking during pregnancies causes an increase in the risk of ADHD. So can we say, just based on this, that there's a direct relationship or causation of smoking and ADHD? Or are there other things that could be there, right? And that's the problem, right? That's the thing about when you're designing this experiment that you need to think ahead and try to remove. If you look at the solution, it says, it is possible that the mothers who smoked during the pregnancy are also more likely to have unhealthy diets, right? I mean, if you look at the smoking, if you look at the cigarettes, all it says, oh, if you're pregnant, you shouldn't smoke. It could cause birth defects and all this blah, blah, blah. And yet the mothers who smoke still disregarded that and smoked. Well, these are people who are also probably more likely to drink heavily or do other unhealthy habits, all right? Okay, so you don't really know if the smoking itself caused the ADHD, or if it was the alcohol, or if it was the, I don't know, the Twinkies that they were eating, or whatever it may be, okay? So you have all these other confounding factors that you need to try to eliminate, okay? Now, if you go down to the bottom of page 243, there's a definition of the experiment. An experiment deliberately imposes some treatment on individuals to measure their responses. So again, this is different from the observational study. In an experiment, you're actually imposing treatment. You're doing something to the individuals. You're exposing treatment. So if you are trying to find out the effect of how large a pea or how many peas a pea pod produces or a pea stem produces when it has lots of light versus less light, right? You would actually expose one to lots of light, and the other one you would have less light. Okay, so this would be an experiment because you're not just merely observing it. Right? You're actually imposing, you're blocking the sun on one of them, right? So you're imposing treatment. So it's an experiment versus, so it would definitely not be called an observational study, okay? Now on page 244, there is a thing called a placebo. And most of you have heard what a placebo is. And so if you read the definition of placebo, says, a placebo is a treatment that has no active ingredient, but is otherwise like other treatments. In other words, if you wanted to, again, let's say that they're doing the vaccine for the COVID-19, right? So if they're doing they're going to randomly select 100 people, separate them randomly to half into 50 and 50 groups. In one group, they're going to give you the actual treatment that you're giving, right? Whatever the vaccine is. And on the other half, you're going to give them a placebo. You're going to give them just saline solution, a salt water thing, right? That does nothing for you, but so that you don't know whether you're actually getting something. Okay. For some things, the placebo effect is pretty big. Okay, it's been scientifically proven that you can give people who are like having a headache, and you can give them sugar pills and tell them that it's aspirin, and like 1/3 of them will say that, oh yeah, my headache went away. Okay, so the placebo effect for certain things are up to 30%. Okay, right. So let's look at the example, the Facebook and financial incentives. Problem. In each of the following settings, identify the explanatory and response variables, then determine if each is an experiment or an observational study. Okay. A. In a study conducted by researchers at the University of Texas, people were asked about their social media use and satisfaction with their marriage. Of the heavy social media users, 32% had thought seriously about leaving their spouse. Only 16% of non-social users and non-social media users had thought seriously about leaving their spouse. Okay? So first of all, what is the explanatory variable? What is the response variable? Okay, what changed and what thing changed associated with that? So the explanatory variable would be the social media use, right? So social media use is affecting or changing the response variable, which is the status of how satisfied you are with your marriage, right? Okay, so that's that. What is this, an experiment or an observational study? Kyle, is this an experiment or an observational study?
A study, because they're not like giving them treatment, they're just asking questions.
So basically, yeah, so they're just observing, right? They're not actually forcing anyone to go on social media or stop using their social media, right? So it's an observational study. Good work. Okay, let's get B. In a diet study using 100 overweight volunteers, 50 volunteers were randomly assigned to receive weight loss counseling, monthly weigh-ins, and a 3-month gym pass. The other 50 volunteers were given financial incentives, earning $20 for losing 4 pounds a month or paying $20 otherwise, along with the counseling, weigh-ins, and gym pass. The group with the financial incentives lost 6.7 more pounds on average. Okay, so what's the explanatory variable here? It is whether or not the financial incentives were given, right? That would be the explanatory variable, and the response variable would be how many pounds that they lost, or their weight loss, and how many pounds, right? That would be the response variable. Now, is this an experiment or an observational study? Caden?
Would this be an experiment because they gave them the choices?
Correct. Well, no, because they gave them money, right? They gave them
Yeah.
money, right? Experiments, right? And also they gave them the gym pass and all these things, right? So they're actually imposing something on the individuals, right? So there was a treatment that was imposed on them. Okay. So that's why it would be an experiment. Okay. Okay, let's move on to page 245, language of experiments. Okay, so the language of experiments. So these are definitions Okay, some of the words that we would use. So definition, a specific condition applied to the individuals in an experiment is called a treatment, okay? So if you were given the vaccine for the COVID-19 or you were given a placebo, that's the treatment, right? If an experiment has several explanatory variables, a treatment is a combination of specific values of these variables, okay? So in some studies or experiments, you can give them not only one dose of treatment, you can give them like 5 doses, right? So not only would you be doing a placebo, you could do 1 or 2 or 3 different levels, right, of treatment, okay? And so that's that. And then an experimental unit is the object to which a treatment is randomly assigned. So this would be the people here when you're doing the COVID, right? That's an experimental unit, okay? When the experimental units are human beings, they are often called subjects, okay? So subjects, all right? Let's go over to page 246. There's another definition there between factors and levels. In an experiment, a factor is a variable that is manipulated and may cause a change. The different values of the factors are called different levels. So, in other words, if we are going to do a treatment for not necessarily COVID, but something else, I know some other drug, right? So if I'm going to give them one group, I'm going to give them a shot. The other group, I'm going to give them some natural herb. And the third group, I would give them nothing. Now, even within the group that I'm giving the natural, or the shots, I can give them 1 or 2 or 3 shots, right? So there would be different levels of treatment, okay? So there are 3 different explanatory variables here, right? Giving them nothing, giving them natural herbs, and giving them shots, right? So there are 3 different explanatory variables. And even within that explanatory variable or with the shots, there are different levels of treatment, okay? So that's that. Okay, so let's go and do the example there, the 5-second rule. Have you ever dropped a tasty piece of food on the ground and quickly picked it up and eaten it? If so, you probably thought about the 5-second rule. Does anybody know where the 5-second rule started? Does anybody know where it's alleged to have started, I guess? I think I was told it was like KFC. Is that KFC, if the workers dropped a piece of chicken, as long as you picked it up within 5 seconds, you could resell it, I think. That's where it was alleged to have started with, all right? Okay, so anyway. The rule is based on the belief that bacteria need time to transfer from the floor to the food. Okay, so, right? So that's basically what they're saying, right? But does it work? Researchers from Rutgers University put in a 5-second rule to the test. They use 4 different types of food: watermelon, bread with butter, and gummy candy. They drop the food on the floor onto 4 different surfaces: stainless steel, ceramic tile, wood, and carpet. And they waited for 4 different lengths of time: less than 1 second, 5 seconds, 30 seconds, and 300 seconds. 300 seconds meaning 300 seconds, right? Meaning 5 minutes, I guess. Finally, they used bacteria prepared 2 different ways: in a tryptic soy broth or a peptone buffer. Once the bacteria were ready, the researchers spread them out on different surfaces and started dropping food. Okay, A. List the factors in this experiment and the number of levels for each factor. So the factor is what? The type of food, right? The surface that they dropped it on, and then the amount of time that it stayed there, right? And also the method of the bacterial, right? So there are how many different types of food were there? So there were 4 levels, okay? Because there was watermelon, bread with butter, and gummy candy. And then the type of surfaces, there were 4 different levels again, right? You had the steel, ceramic, tile, you had the carpet, and what else did you have? Or something else, wood, okay? The amount of time, there was a length of time, 4 different times there, and again, the different types of treatment methods, right? I mean, the methods that the bacterial preparation. B, if the researchers used every possible combination to form the treatments, so that'd be 4 times 4 times 4 times 2, right? There would be 128 different treatments, right? Because each explanatory variable, each 4 of those explanatory variables had 4, 4, 4, and 2 levels. List 2 of the treatments, okay? The book says watermelon, stainless steel, less than a second, tryptic soy broth. Or gummy candy, wood, 300 seconds, peptone buffer. So each one of these will be different, and there are 128 of them. Okay? All right, moving on. Comparison. Okay, in comparison, what we really want to talk about, if you flip the page, is what you call a control group. Control group, okay? That is where you draw the baseline data from. Okay, so if you look at the control group on page 248, it says, in an experiment, a control group is used to provide a baseline for comparing the effects of other treatments. Depending on the purpose of the experiment, a control group may be given an inactive treatment, which is basically a placebo, or sometimes an active treatment or no treatment at all. Okay, so the different ways, but you have to have a control group so that you can actually compare the control group to a different group where you're actually doing something to it, right? Where you're actually giving the treatment so you can compare them, right? Because let's say you want to you're trying to find the effectiveness of a drug, and you just took 100 people and you gave them all to them, right? And you said that, well, 50 of them got better, 50 of them did not. Okay. So can you say that's 50% effective? No, you don't. You don't know, right? Because some of them might have, the treatment did not work for them and they got better just naturally, right? So in order to keep those guys or keep that into consideration, you have to have a control group where you're not giving them any treatment. Okay. All right, we'll stop right there. And that's the first part of 4.2.